Or you want to find the limit as x approaches infinity of this function is 4 over 3x minus sine x. Okay, so when first you probably do is plug in like a really, really large number here, right? Okay, I don't know, like 1,000, a million, it doesn't matter, right? The trick here, not the trick, but the key here, what is the limit as x approaches infinity of sine of x? Okay. Well, we know that sine and cosine are wave functions, right? Actually, this limit doesn't exist. Okay, if you look at the graph of sine, right, it's just a wave. So as x gets really, really large, right, there's no single number that approaches, right? It's the same holds true for cosine also, right? The limit as x approaches infinity of cosine of x, well, that doesn't exist either, right? Because it exhibits the same characteristics. Okay. Similarly, two other well-known properties, right? The limit as x approaches infinity of sine of x over x, right? That's just equal to 0. And the limit as x approaches infinity of cosine of x over x, that's also equal to 0. All right? So these are some properties that you do want to remember. Okay, so once again, if you just plug an infinity in here, right? Well, this doesn't even exist. And this is just infinity, so we can't really just do this, right? We gotta do something here, right, to sort of figure out what this limit is. Well, because we're finding the limit as x approaches infinity, we can always use that property. Let's divide everything by the highest power in the denominator. In this case, we'll divide everything by x. Okay, so we'll take the limit as x approaches infinity, and I'm going to divide each term by x. So I get 4 over x there. I get 3x over x. And I get sine of x over x. Okay. Now, in this case, only that cancels out, right? So what I can do now is I can take the limit of each term individually or separately using the limit laws, right? The limit as x approaches infinity of 4 over x. And then I'm going to take the limit as x approaches infinity of 3. And then the limit as x approaches infinity of sine x over x. But wait a minute, check out what happens, right? This is just equal to 0. This is just equal to 3. And this is just equal to 0. Notice what we get. We get 0 over 3 minus 0. That's just 0 over 3, which actually is a number, right? That's just equal to 0. So what does that mean? It means that this limit, right? The limit of this function as x approaches infinity, right, does equal 0. That's going to be what's known as a horizontal asymptote at the line y equals 0.